Hello everyone. Going to be a quick video. I just wanted to cover a couple things that we didn't get to do in class. One of them specifically is going to be a change of base question, what I can consider to be a challenging change of base question. And then I have a couple examples where we're going to find the equations of some exponentials from a graph, and a couple where we're going to find equations of logarithms from graphs, like we had on the back of that worksheet that so many students are having questions on. So I figured quick little video, help us all out with that. Let's get right to it. First of all, that change of base question that I wanted to do in class today, didn't get a chance to, is boom, right there. And our job is to try to simplify this to a single logarithm. So one logarithm. Now we can't just condense this thing the way it sits, and the reason why is because these two logarithms have different bases. We can only use our laws of condensing when our logarithms have the same bases. So our only option for this question then is to use the change of base formula. And change of base says that we can write any logarithm in any base that we want to. I think the easiest base to choose then would be base 10, the common log. So what we're going to do is we're going to write this as log of 5 divided by log of 2. And we'll write this as log of 3 divided by log of 8. That clattering noise you hear is my dog, being the biggest nuisance in the world, dropping a bone right next to me. Anyway, what was I doing? Oh, that's right, math. See? Yay, math. Anyway, here I'm trying to add two fractions, which can only be done if they have the same denominator. Lucky for us, 8 is a power of 2. This 8 right here can be thought of as saying 2 to the third, which would give us the ability to take this 3 and move it to the front of this logarithm right here. Now once that 3 has been moved to the front of that logarithm, what we're going to have is 3 log of 2. Now our denominators are nearly the same. All we need to do is get a 3 log of 2 right here. So we're just going to multiply the top and bottom of this fraction by 3. Now they have the common denominator. When we write these as a single fraction, it's going to give us the ability to condense on the top of this fraction because these two logarithms have the same base. However, please remember that you can't condense logarithms until there is not a number sitting in front of them. This logarithm has a 3 sitting in front. That can't be. So we're going to have to use our rules again, move this 3 back into our exponent position. Now I know 5 to the third power is a big number. I'm not going to ask anybody to have that memorized. What I want to know is, do you have the ability to pull this off? I'm running out of vertical space, so we're going to come up here. 5 to the third power is the number 125. So it gives me log of 125 plus log of 3 over, you know what, while we're at it, since we're going to be trying to write this as a single logarithm here in a minute, which means I'm going to have to undo change of base that we did right here, I'm going to go ahead and move that 3 as well and turn this back into a log of 2 to the third, which is log of 8. Up here, these two logarithms have the same base, so when I add them, it's going to create a multiplication in the argument. Log of 125 times 3 divided by log 8. And once again, don't stress out about the big numbers. I got your back here. I just want to make sure that you understand how the concepts are working. 125 times 3 is 375. This gives me log of 375 divided by log of 8. And all the way back to here now, where I used change of base to write log base 5 of 2 as log 5 over log 2, I can undo this process now, base bottom, so this is going to be our base, and write this as a single logarithm, log base 8 of 375. So this and this are exactly the same. Woot! Okay, now on to the part that everybody was waiting for after my wife interjected into the video, is getting equations from graphs. So here we have our first exponential. You don't need a warning. All right, anyway, our exponential here clearly has a horizontal asymptote right here. So you know what, this pen sucks. Let's get a better pen. Here we go. Horizontal asymptote here at y equals -5. And one last thing, since these questions on my test will be multiple choice, you'll be able to see that all of the questions have the same base. So I'm just going to go ahead and tell you what the base of these questions is. Of course, I've forgotten, so I need to take a peekaboo at my answers here. All right, this one is a base 3 exponential. Could I find that base without looking at my answers? I could, but I'm not asking you to, so I don't feel like having to do it on video either. There. All right. All exponential functions are supposed to have the x-axis, which is y equals 0, as their horizontal asymptote. Because this one's horizontal asymptote is 5 below where it should have been, so right there at y equals -5, we've been shifting this thing down 5 units from the parent function, so k must be -5. It's right in green this time. Hopefully that shows up as not purple. This is purple, not black. -5 is our k value. There. This point right here is 2, -4. But it is the point that is closest to a horizontal asymptote. The point closest to the horizontal asymptote is always going to be the result of your exponent equaling 0 every single time. So I know this x value, 2, makes this exponent, x minus h, equals 0. I hope they can hear the dog howling in the background because she's locked up. I want you all to know that are watching this video, I want you to succeed so much that I've caged the dog. What do you... It's like, this is top tier YouTube content right here. They're going to be able to hear all of this. They're going to hear you digging in the bag of treats. They heard your chair. They hear the Minecraft zombies behind me. They're hearing all of it. Anyway, what was I doing? Oh, that's right. Math. Okay, so this x value is going to make this exponent equal 0. So we say 2 minus h equals 0. Add h to both sides, you get h equals 2. That's one less unknown in our equation. H is 2. I wrote minus k here for some reason when I knew that was -5. Oh my gosh. I've done this before, you can tell. At this point, you have a single unknown, a. Lucky for us, we have one more x comma y, 3 comma -2. We can take that x and y, drop it here and here, and that is going to allow us to solve for our missing a value. Let's go. Y is -2. I have an unknown a. I have a 3 being raised to a 3 minus 2 minus 5. Well, 3 minus 2 is 1. So this is 3 to the 1, which is just 3. We can add this 5 to the other side, and then divide both sides by 3, and what you get for this one is that a actually equals 1. So your grand finale equation for this graph is y equals, there is no reason to write the 1, 3 raised to the x minus 2 minus 5. Ta-da! Okay, let's do it again. Now this exponential clearly has its horizontal asymptote right here at y equals -1. But if I use green this time, see if it'll stand out well on the camera. And like I said before, since these kinds of questions are multiple choice, sorry, I just got these lips on my test, you're going to know what the base is because all the options will have the same base. This one happens to be base 4. And that's actually why my two pretty points here are stretched out so far away from one another. Base 4. So we have y equals unknown a value, 4 raised to the x minus h plus k. Once again, this y equals 0 should have been our horizontal asymptote. It has been shifted down 1 to -1. All of our vertical shifts are going to be found back here. So k for this one happens to be -1. There. Like I said before, the first pretty point, meaning the one that is closest to the horizontal asymptote, is always going to be the x value that makes the exponent equal 0. This point is at -1, -3. So x equals -1 makes this exponent equal 0. If you add this h to this side, what you get is -1 equals h. Be careful when you plug this in, because there's already a minus sign here in front of h. So if a 4x minus -1. And there's a -1 sitting right here. Last thing we need to do is find a, and we're going to find it the exact same way we did last time. We can use this x comma y to pull that off. This one happens to be the y-intercept, coincidentally, and the coordinates for that are going to be 0, -9. So we can throw those two values in for this, and all we have to do after that point is solve for a. Let's make it happen. -9 is my y value. My x value is 0. Now 0 plus 1 is, well, 1, and 4 to the 1 is 4. So what we have here is -8 equals 4a minus 1. Something's gone horrifically wrong here. Oh, I see what it is. First of all, my phone is now interrupting my video. It's fantastic. I wrote -8 instead of -9 by accident. Let's see if I can fix this. Hey, look, it says -9. I did it. Okay. If you add this 1 over here, that's where that -8 is going to come from that I wrote down, thinking ahead here. And then dividing both sides by 4 gives us our a value of -2. This exponential equation then is y equals -2. 4 raised to the x plus 1 minus 1. And there it is. I have to pause the video so I can shut my phone up. All right, now we can move on to logarithms. Start with this one here. Again, multiple choice. So you're never going to have to guess what the base is. You're not going to have to solve for the base because the questions will tell you. This logarithm is base 4. So we have y equals a log base 4 x minus h plus k. Logarithms have some very specific rules that we have to pay attention to. 1. X minus h is not allowed to equal 0. What that means is whatever value of x makes it equal 0 is not allowed. That is the x value where we will find this vertical asymptote. So what we can see here is that x equaling -3 is going to make the argument equal 0. So go, okay, fine. If x is -3, this argument will equal 0. add h over here, and we get that negative 3 is what h actually equals. Again, be careful. When you're throwing that negative 3 in here, you have a minus sign already, so it's minus negative, which is going to be plus. So we have y equals a log base 4 of x minus negative 3 plus k. Just like with exponentials, the point that is closest to the asymptote is always going to follow a very specific rule. For the exponentials, the point that was closest to our asymptote was going to be the x that makes the exponent equal 0. This time, it's going to be the x value that makes the logarithm equal 0. Well, logarithms are only 0 when the argument is 1. Because our special log rule says log base, and nobody cares what the base is, log base b of 1 always equals 0. This first point is always going to be the place where the logarithm has a value of 0, which means x plus 3 equals this argument of 1. So x equaling negative 2 is obviously going to be what makes the argument equal 1. But what else is going on there is this y value of positive 1. We can use that here. So we say this point is negative 2 comma 1, like that. Throw that y value right there, 1. I'm going to throw that x value right there, negative 2. We can see that, yes, indeed, negative 2 plus 3 is 1. This is a multiplier, but this logarithm has a value of 0 because of that rule. So all of this essentially goes away for this question because a times 0 is going to be 0 no matter what a is. Oh, look at that. K is 1. That gets us to y equals a log base 4 of x plus 3 plus 1. The very last step then is to use the last coordinate that we know, which is going to be negative 1 comma 0. Throw those two numbers in as our x and our y to solve for a. Y is 0. You know what? I'm going to run out of vertical space, so let me go over here for this one. Y is 0. Eek. So I greased my pens. And we're going to throw that x value in to the argument. And we're going to see what happens. Well, negative 1 plus 3 is 2. And luckily, this is one of the things that we can actually evaluate. Now, it's not the easiest thing in the world, but we can evaluate it. Remember, log says what power of. So this actually says what power of 4 gives me a 2. Let me reword that. 4 to what power equals 2? So we're thinking like this. 4 to what number equals 2? Well, 2 is the square root of 4. And square root is the 1/2 power. That means this logarithm has a value of 1/2. So I have 0 equaling 1/2 of a plus 1. Subtract 1 to the side. And then simply get rid of our fraction by doubling both sides. Because 2 times 1/2 is 1. And what we get is that a equals negative 2. Final answer, y equals negative 2 log base 4 of x plus 3 plus 1. And I got cute with the answer. Look, 1, 2, 3, 4. And then the last one, and we'll call it there. Boom, baby, right here. Now this logarithm, and it is a logarithm, is extremely vertically stretched. I mean, look at this thing. Whee! But it is a logarithm, and I tried to capture its vertical asymptote. It's right there. So this one's vertical asymptote happens at x equals -1. Believe it or not, this one's actually a base 2 logarithm. But we're going to follow the exact same process. Asymptotes occur when we break the rules of a function. The rules of a log function is that the argument must be positive, meaning the argument cannot be 0 or worse, a negative number. So x minus h can't be 0. That means this x value of -1 minus h gives us that 0 that's not allowed. So you add h to this side and you get that -1 equals h. That one should always be fast and easy to find. Be careful. Again, it already says minus, so we're saying minus -1. X minus -1 plus k. Come here. 0, -2 is an x, y. That can be thrown in. Y here, x there. Zero plus 1 is 1. That means this right here says log base 2 of 1. And if you remember from the last example, this is one of our special logarithms. Log base b of 1 is always equal to 0 because this is what power of, who cares what the base is, but 2 to what power gives me this 1? The 0 power. That means this logarithm right here has a value of 0. Big old goose egg. And a times 0 is always going to be 0. So, once again, that means nothing, and we can see that k is -2. Y equals a log base 2 of x plus 1 minus 2. Last bit of useful info. You know what? I like green. Coordinates here are 1, 1. And we can throw that x and that y in here and here, and it actually doesn't matter which one is which. We get lucky that they're the same number, but that's going to allow us to solve for a. 1 here, fill out the rest of this thing. This says log base 2 of 2. This allows me to highlight my other special logarithm. Anytime the base matches the argument, the log's value is going to be a 1. Because it, remember, says, what power of 2 gives me this 2? The first power does. So that makes this whole logarithm right here equal 1. This is a times 1. So it gives me 1 equals a times 1, which I'm not going to write, because it's just a, minus 2. And all we have to do is add 3, or excuse me, add 2 to get the answer of 3 for a. Which gives us our result of y equals a value of 3 log base 2 of x plus 1 and then minus 2. There. I hope that clears up some confusion, and I hope that it wasn't too remarkably distracting between my dog and my wife and Minecraft and the dog treats and the, on and on and on.